Yeah, you should just shout trans. Wait, why were you there at 5:15? Mr. Park?
Welcome to another Mr. Park vlogs.
I'm Mr. Park?
I'm his assistant. Today we'll be discussing parametric. See, it was all planned.
It is the first
You guys need to
section.
leave her.
We have a substitute teacher today. His name is Mr. Park. This is the substitute teacher, Mr. Park's assistant. We call him Tran. He has the donuts.
Good. Okay, does any last chance for questions on the practice test?
We didn't even finish all of them.
Yeah, I know.
Did we have like number 9?
Last chance. What?
Number 9? I think it was 9 or 8. Yeah, 8 for sure. Oh, 8.
You just look at it.
8 and 9. Yes. And then what do you do?
You wish you get a problem like number 8 on the test.
Do you still finish your
Well, this is the only dark green shirt I had.
I don't care.
I like it.
so stressful.
What's today's dress?
Dark green day.
It is?
Then you're such a nice person.
That was
Obviously
yesterday.
not sprinting.
Oh, wait, teachers
I think
have
faculty
a thing
relations.
this week?
Wait, teachers have jobs?
What's today's day?
Today is every department wears a different color. So math, dark green. I don't know.
Oh, green. Right here.
I feel like
Are you for real?
No, light green is a different department. Math department is dark green, like Tran.
The substitute teacher.
What does this thing here do? It makes it alternate, right? Because what happens when you plug in 1, 2, 3, 4?
1, -1.
You get 1, -1. 1, -1. So this is the same thing as this. Now you might be asking, well, why don't I just write that?
You want
Well, just like the book, doesn't the book write cosine and pi sometimes? Just to throw you off? It's not to throw you off, it's to see if you understand what's going on. So, all this thing here does is make it alternate positive, negative, positive, negative. Now, which means, this is an alternating series, you can use the alternating series theorem or Leibniz's theorem. So all you gotta do now is ask yourself, does this thing as a sequence go to 0?
Yes.
Yeah, so this thing converges.
Oh.
Now, does it converge? Absolutely. In other words, if I took the absolute value of all the terms,
No.
No.
No, it does
you
not.
would, you would end up with this, right? If you take away the negative, the thing that makes it alternate.
Yeah.
Does that series converge?
No. P
No,
series.
because this is a P series, or P is 1/3,
Yeah.
diverges to infinity, so therefore, it only converges conditionally.
Oh.
Because if you take the absolute value of every term, it diverges.
Yeah.
Okay, that's easy enough.
Can you
Now,
do
what
a-
about number 9?
Can you do the harder ones for me, please?
Well, see, since I only can give you a few, you know I'm gonna make you use different tests, yeah? Why would I just give one problem that's like the same? So, they're pretty much all different, right? For those of you who actually did it, yeah?
We do F.
Can you do all the hard ones?
I see no hard ones.
In the eyes of me.
Okay, let's start, okay, because some of you are still befuddled because you have so many problems to do, yeah?
Yeah.
So like 9A, Tran. Everybody else knows because they've been at least doing a little homework. What about you? 9A, converge or diverge?
1/3.
That's not even an answer.
Converge.
No, it diverges, and what's the reason? No!
And term
This
test
is-
for divergence.
this is
What
how-
song are we on?
You're just trying to remember some terms you hear
You said
in class.
1/3. We're correct.
Donut.
Okay, look, if this thing as a series, what is the limit of that thing?
1/3.
Okay, 1/3, I agree. Is that 0?
No.
No, so therefore it diverges.
Right.
And what's the reason? What you have to state, if you don't state the reason, you only gonna get 1 point. The reason is 3 points.
And
Okay, let's say
term
2
test.
points. And term test. Does everybody understand? That's the first thing you should check. If this thing does not go to 0, then automatic diverge. But see, that's the only one. All the rest do go to 0. What happens if it does go to 0?
Ratio.
Then it might converge, and then you have to use these other tests. This is crinkly business. Okay, now somebody said do all the hard ones, not like, I don't know, what do you consider hard? Huh?
How do we do odds? And
F.
Like when you see E, if you see something with factorials, what are you probably gonna do?
Cross out the X.
No, the ratio test. The ratio is a good test when you have factorials
Because
and
it gets
powers.
rid of it.
Okay, let's do F then, because we haven't seen this one
Can you
many
do-
times.
You do the integral test, so then.
Okay, very good, some people know. N equal 2 to infinity. How come I started this one with 2? Anybody know why?
Because you don't want to make the denominator 0.
Because natural log of 1 is 0, and you can't have 0 in the denominator, that's why. So you have to start it with 2. So how does the integral test work? If I do an integral from 2 to infinity of 1 over x natural log x quantity squared dx, then what? If this one converges, then that one converges. If this one diverges, then that one diverges. Okay, is that integral easy to do? Yup, U substitution. U equals
ln X.
ln x. du equal 1 over x dx. See how you got dx over x there? So this integral becomes u squared on the bottom, and then du. And what are my new limits of integration? Natural log 2 to infinity, but then we're going to put the b there and take the limit as b approaches infinity, correct? Because this is an improper integral. What is the antiderivative of u, 1 over u to the negative 2? Negative u to the negative 1. From natural log 2 to b, factor out the constant. 1 over b minus 1 over natural log 2. Now I'm going to take the limit as b approaches infinity. What happens with that? That goes to 0. So this thing is equal to 1 over natural log 2. Finite number, it converges. So therefore this converges by the integral test.
Was that the only test you could
You might be able to use another one.
limit?
No, lots of them you can use several tests, as long as you justify it on the paper.
is there like one test that works for everything?
Limit.
Okay, if you wanna go into the test with just one thing in your tool belt, you have to do the limit comparison test.
Okay.
Which one was that?
But then maybe the ratio test is better. I don't know, I think you should have at least 2 things in your belt.
Okay.
Why not have them all?
What's the ratio test?
Yoshida.
Oh, and
Okay.
oh, limit comparison is though like comparing.
Why? No,
Stuff to
you
like
don't even
one.
get,
You don't.
you don't even get to the
Yeah,
comparison.
then
If you
you.
don't need it, could you compare it to like 1 over
As it
2?
approaches
And
infinity.
then when you cross multiply,
And
it's
then
always
it's
greater
direct
than what we
Wait,
have.
we're gonna talk about cross multiply.
Like, you multiply each side.
Limit is when you
by
put
one.
it over each other, right?
Then
And
you
you
get
take the
n
limit
cubed
of
is
it.
greater than
If
3n
it's
minus
a
2.
finite number, then
Which is
either
true
it
for
goes.
large.
No, stop. See how you make things more complicated than it needs to be?
The ratio test is
Some-
the.
If it doesn't go to 0, diverge. That's all you gotta do.
I'll
Don't make it more
go for it.
complicated. Okay, is there another difficult one there?
No.
I don't see it.
Oh, come on, Trevor.
Okay, well,
I'm so hungry.
okay, yeah, I'm very hungry. Shit,
I
straight
can
up.
tell.
Are you going to Popeyes, Mr. Park?
What?
Are you going to Popeyes?
No, I already went to Charhansat this morning.
Ah, TFT.
What's Charhan side?
In Chinatown.
Yeah, it's in Chinatown. It has good manapua and stuff.
Can we go?
Wait, you went this morning?
Yeah, because it opens 5:30.
Oh, seriously?
So I went, I got there around
What do you
6, I
get
think.
from there?
What?
I had 2 manapua, 2 pork hash, and 1 layered rice cake.
What's inside the monopua?
Oh, there
What's
you go.
inside the monopua?
Like chopped up pork.
Oh, char siu.
Char siu?
No, but it's chopped really fine though.
So it's more delicious.
Yes, it is.
More surface area.
No, stop making me talk about food. Okay, but before we do parametric, I want to do this problem. I thought I assigned it in the book. Did I assign this problem in the book?
You did.
And everybody got it? I know we did it in PCH last year. You asked me about it? We did it on the board? No. Okay, I'm gonna do this again because, maybe you might see something similar on the test. Just like last year at PCH, we did that in the homework and then it was on the test, right?
Oh, that looks like geometric, 2 to the end.
Okay, does this series converge or diverge?
Fat boy.
I mean, just tell me, converge or diverge?
Converge.
Yeah.
It converges.
Yeah.
What test did you use?
Geometric 1/2.
No, this is not geometric because of the end.
Limit comparison test.
Okay, no, enter, this thing goes to 0. This thing goes to 0, so it might converge. If this thing does not go to 0, then
The ratio
automatically
test.
converge. So either ratio test or the root test would work well in this one. Yeah.
What's the root? Oh, did we learn that yesterday?
You take-
Oh yeah, we did this
You
yesterday.
take the nth root of this, take the nth root of this.
We did this yesterday.
We did this.
Yeah, I know.
Oh.
And then you get the nth root of n all over 2.
And you gotta
Now you
assume
take
that
the limit
It's one.
as n approaches infinity
What happened?
of this. What does that go to?
One.
1. That's 1/2, which is
Oh.
less than 1. Converge.
Oh, geometry. Man, you
It's-
gotta know all these like less than
Go.
one.
I want you to write geometry in every problem.
Parametric.
Okay, so this converges, but I want to know what it converges to. You're gonna actually compute this number. Okay, now we did this problem in PCH, and last year I remember you said, "Oh, that's really neat."
Bow to.
And then I think I changed it to a 3 on the test. And all hell broke
Oh,
loose.
no.
693.
Okay, so I'm gonna show you this problem because I don't want hell to break loose. Okay, let's write out the first 4 terms. Plug in 1.
I'll do the first one.
2 fourths, 3 eighths,
I see your
4 sixteenths.
Yeah.
Yeah, you see a pattern. You know what's the pattern, Dan? That's the pattern.
Oh.
Mr. Park, I don't know what to do. Well,
Partial sum.
does anybody remember what we did last year?
Partial sums.
Okay, you can do partial sums, but there's a
Major.
Okay.
No, you split it.
no. That's no. How are you gonna do partial fractions on this? What?
You split the 2 fourths
Find a
into
pattern.
1.
Wait, you were in my class. You're supposed to know this.
1/4, and then 3/8 to 1/8, 1/8, 1.
Yeah, yeah, I know. Cause
No,
this
it's
last year. Try it. What about you?
Oh, it's for the.
I don't recall.
Yoshida, you're supposed to know this. This is for the
sorry,
other
sorry.
people.
Wait, we were in that class.
Yeah, we were in good class.
So do you remember this?
No.
Negative.
That's what I thought.
Look for a pattern.
Okay. Is this a geometric series?
Yeah.
Yeah, so we can compute that. Yeah, but Mr. Park, it's not the same as the original because I got the 1/2, but this is 2 fourths. So then you do this. Does this ring a bell?
Oh,
Yeah.
Oh. See, now you got 2 fourths. See, that's 2
Yeah,
fourths.
yeah,
Yeah, but Mr. Park, when you get 2 eighths, that's 3 eighths. So then you do
Sorry,
this.
Abby.
Oh. Yeah, but Mr. Park, that says 4 16ths. So then you just do
What
this.
about 5/32?
And then you just keep on going like that. Now is it ringing a bell?
That's why the 1/2 thing works.
Okay, so look at this first one. Hey, that's a geometric series.
1.
First term all over 1 minus r. What is that? Who said 2? That's 1. Tran, you're getting it all wrong.
Try to split it too.
2.
Okay, look at the second line. Hey, that's a geometric series.
1/2.
First term all over 1 minus r. Hey, that's a half. Okay, third line. Hey, that's a geometric series. 1/8 all over 1 minus r. Hey, that's 1/4. Hey, the fourth line, that's also a geometric series. Hey, I get it. It's just that the first term is different.
Mr. Park, question.
Okay, wait. I'm gonna do this one. Plot. Okay, that's equal to 1/8. Okay, question.
Maybe that's why the 1/2 thing works.
What 1/2 thing?
Just like geometric.
But it's not geometric.
Well, like maybe like
Okay,
that
here.
shortcut.
I'm not gonna stop you. Do whatever you want on the test. You just pay the price.
Dude, make that your proof.
So, would you agree?
Master.
Would you agree that the sum of this series is simply
I'm gonna do it.
add up all of these numbers? Of course, it keeps on going like that, right? But isn't this an infinite geometric series in itself? No, the common ratio is 1/2. So, how do you add up all of these numbers here? First term over 1 minus r, and you get 2. There you go. So this is equal to 2. Boom. So this is what Hanuman is, this is your proposition. So if I change that to a 3, the answer must be 3. Yeah, I like it. Well, why don't you look at your quiz last year? Let's see.
I don't have
Did you keep your PCH base?
Yeah.
Mr. Yeh students, did you do this?
It's in my binder.
Well, you have to because it's on the thing.
Try,
The practice
for
problems,
funsies.
Choi, do you remember? No. Abe.
Of course.
Well, I have no sense even, yeah.
Try for funsies.
Why, did you do this problem in PC? No, I didn't think so. Okay, you know what I'm gonna, here, maybe I'll just change it to like an E or something, that'll make sense. Or a pi.
Oh, pie.
Just make it pi to the
Make
E.
it Lin too.
We can lin.
0.693.
Okay, let's think about that one for a minute. Why would
0.69.
Lin 2 not work?
It would work.
What?
It wouldn't.
No, because 1 over Lin, why am I saying Lin?
It's less than 1.
Yeah, that's a mistake.
No, so it's gonna be greater than 1.
Yeah.
Yeah, this is smaller than 1, so it's gonna be greater than 1.
Wait, it's not geometric though, right?
No, but then still, it's gonna get bigger. So no, can't do, thing gotta get smaller, it's gotta go to 0 to even have a chance.
Lin 3 then.
Lin 3, stop with that Lin thing.
Lin 0.
Okay, let's just do what we gotta do so we can go to lunch. Okay, today we do parametric equation. There's only 3 sections left and we're done. We got parametric equations,
Polar.
vectors, and polar, and we are done.
We're doing vectors again?
Yeah, it's easy. Vectors, you guys, that's why we did so much in last year in PCH. If you could just remember a modicum of it, it would be like so easy.
Yeah.
Modicum.
Vectors are not even.
Okay, here we go.
Parametric
Parametric equations. Now,
perpendicular plane.
we did a review of
You're cool.
parametric equations in August. Does anybody remember the review in August?
T.
Maybe it's better not to do a review then.
Particle.
Mr. Ye's class, they don't do a review.
Along a fixed line.
Okay, let me give you an example of a set of parametric equations. X, let's,
Sine t.
oh here, cosine t,
Y equals sine t. X squared plus y squared equals 1. It's the same.
Ooh,
Okay,
circle.
what is the path
Wait,
that the
Trent, you're
particle
actually-
is traveling on? How do you find the rectangular equation that the particle is traveling on?
R equals something.
Square the equation, square the first equation. Remember I told you guys last year that
Oh,
When
if
you
you
get
get
in
in
okay.
trouble
Why don't
with
you
squaring
square
the
everything?
equations.
Y squared equals add them.
Now, what should I do with these equations if I want to eliminate the t? Should I add, subtract, multiply, or divide? Add, and you get x squared plus y squared equal 1. Yay!
You somebody.
That's a circle.
Very useful.
Ellipse.
It's a circle. Okay. Now, how is the particle traveling on the circle? Now, normally, if they don't give you a restriction for t, then you just have to assume t is all real numbers. Okay, but in physics and engineering, t represents time, so we'll just say it's greater than or equal to 0. Now, last year we made a chart. You guys remember that, like this? We made a chart. But we're in BC now. We can do the chart in our head.
Of course.
Okay, if I plug in 0 for t into the original equations, where is the position of the
1, 0.
particle? 1, 0. So this is, we call this the initial position of the particle. Initial position. Where would the particle be? Assuming t is measured in seconds, where would the particle be when t is pi over 2 seconds? Plug in pi over 2.
0, 1.
0, 1. Oh, so now the particle is here. Now what happens when t is pi? Plug in pi. Yeah, so here is the particle when t is pi. What about 3 pi over 2?
Oh, that's the unit circle, Mr.
And then 2 pi goes back here. So what's happening is the particle goes around counterclockwise with a constant speed, like this. And you guys in physics, what is this?
A circle. Circle.
Uniform
Circular
motion.
Oh!
And next section, when we do vectors, we're gonna compute the velocity and the acceleration vectors.
Centripetal.
I believe in you, Tran. You better go to nail this stuff.
Wait, what? What do you say?
Okay, but in this chapter, what we're gonna do is we're gonna do the calculus of parametric equations. Like for example, when t is pi over 4, you can probably guess. When t is pi over 4, what is the slope
Negative
of
1.
the graph here? Yeah, I know. What if it's not like a nice graph that's symmetric?
To
like
take
that?
a
You gotta figure it out.
0.69.
So, what tells you the slope? The derivative or dy dx. But see, these equations are, in terms of t, so using the chain rule,
Yes.
isn't this equal to dy dt over dx dt? You can treat it like fractions.
Oh, cross out the DTs, dy.
Okay, divide top and bottom. Divide top and bottom by dt then, how's that?
Yeah.
Look, you have a fraction, here, like 2/3. Can I divide top and bottom by 5 and get 2/5 over 3/5?
Sure.
Yeah, that's what I did there, except I divide top and bottom by dt. Okay, so for this problem, if you want to find the slope of the tangent line, all you have to do is compute dy dx, which is dy dt over dx dt. Now, here's y in terms of t, therefore what is dy dt? What is the derivative of sine t?
Cosine.
Cosine t. And what is dx dt?
Negative sine.
Negative sine t, which simplifies to
Negative
negative cotangent t. So when t is pi over 4, what happens if I plug pi over 4 into this? You get negative 1. It tells you the slope. dy dx tells you the slope. Okay, and that's easy. Everybody can do that. But now, what about the second derivative?
My dog can do it.
Okay,
Acceleration.
you guys think you're good, yeah?
My dog thinks it's good.
I would put money on it that you're not going to get it. How would you
This is the part you
compute the
wrote it
second?
wrong. It's d squared x, not.
No, that's correct.
Well, why'd you write
That's Leibniz's form of the derivative. Hello.
What?
Yeah.
Wait, you can write x squared?
Swarm.
That's just Leibniz's notation for the second
Why'd you
derivative.
put d squared on? Because that's
That's just how it is.
That's the convention. Okay, how do you compute the second derivative when t is pi over
I
4?
just write 2 lines.
What do you think you would do? Look, here's the first derivative.
Derive cosine.
So just take the derivative of that.
No.
So negative, what's the derivative of cotangent t?
Cosecant.
No, negative cosecant squared t, but I already got a negative, so cosecant squared t. Wrong, fatal error.
1 over cos.
Why doesn't that work? Okay, well, I'm gonna tell you why. You can't just simply take the derivative of that, because, see, this is you're taking the derivative of y with respect to x. X is your independent variable. So this is what you gotta do. Okay, you see this thing?
No.
This is the derivative, see this here, this is the derivative of y with respect to t. Why did I put a y prime there?
That's what I do.
No, that's not right. Sorry. Never mind.
Oh,
That's just, I erased it. I erased it. This, so you want to find the second derivative of y with respect to x. So what you got to do is you got to take the derivative of y prime with respect to x,
Oh my.
and then you got to divide that by dx dt.
What's going on?
Whoa! Trying to sprain my ankle?
The tennis bonus.
Wait, let me look at this. Wait, I didn't really write that, I'm looking at it.
What's going on?
No, you wrote that. You definitely wrote this. Pounds.
It's the derivative of this with respect, see, I did it wrong.
Pounds.
I'm wrong. I did it wrong.
5 is a 9 score.
5, just 5.
I'm taking the derivative of this with respect to t. There you go, now I got it
Oh,
right.
I think that was a mistake.
No, this is the correct one.
But I called pounds.
No, you can't call pounds. Does everybody understand? Because look, if you multiply top and bottom by dt, these would cancel out, and then you get the derivative of the first derivative with respect to x. That's what this is.
Wait, whoa.
No, again, people, you know when you make an integral, it really matters what that dx, dy, or dz, it really matters, or dt. But some of you just leave it off, and the same thing with derivatives. You take the derivative with respect to x, that's different than taking the derivative with respect to t. It's not the same thing. So, this thing here, it means the derivative of the first derivative with respect to x. X has to be your independent variable, not t. So that's why this thing here is the first derivative with respect to t. See how you got the t there? But that's not what we want. We want it with respect to x. That's why you have to divide by dx dt so that these cancel out, and then now it's with respect to x. Okay, if you don't understand that, then just memorize it. Okay? So how do you do this then? Here is dy dx. Take the derivative of that with respect to t. What's the derivative of this with respect to t? Cosecant squared t. But then you have to divide it by dx dt. Well, what is dx dt? Well, dx dt is this thing right there, which is that, negative sine t. And can that simplify? What does this simplify to? Tran, redeem yourself.
Oh, 1 over, no,
Okay, negative. Yeah.
1 over
One.
sine t.
Exactly, 1 over sine cube t. That's correct.
Wow. Because cosecant is 1 over sine.
This is 1 over sine squared. When you divide by a fraction, that's like multiplying by the reciprocal.
Yeah.
I thought that's cosine.
Sine squared times sine is sine cubed.
I thought it was cosine.
Okay, so what is the value of the second derivative right when t is pi over 4 there? What is the value of the second derivative? Well, simply plug in pi over 4. What is it? Negative 1 over, what is
2 negative 2.
1 over root 2 cubed?
2 over 8.
Oh, cute.
What? Look, why are you doing that? 1 over root 2 cubed.
1 over 2.
Okay, I'll write it out. 1 over root 2 cubed.
1 over 2 root 2.
1 over
1 over
2 root 2.
2 root 2. So,
2 root 2.
negative 2 root 2. Now, does that make sense? That the second derivative should be negative there?
Oh, what does it
Yes,
Concave
because
down.
it's concave down.
Yeah.
It makes sense. If the graph is concave down, the second derivative should be negative. Like over here, the second derivative should be positive because it's concave up. So tonight's homework, the first part of the homework is really easy. You just have to compute the first and second derivatives and compute it at certain values. Okay, but then things get kicked up a notch. Okay, you know what? Why don't we just go to that problem that I was gonna do, let's just do it. I hope you guys remember something from IC.
Where are we videotaping?
I just remember that.
X equals, somebody else is absent also.
JC.
No, somebody else also.
Jay.
Oh yeah, Hirano. How
Baby's
come this
out.
time he didn't ask for a video?
Baby's here. Who's back?
Oh, I didn't ask for one.
We did, forgot it was emailed.
Baby's bag is
Yeah, and you look, Ishihara, you didn't ask for a video, but I sent it to you.
Who's back?
Did you watch it?
No. Hey, Mom.
Okay, just for that, Ishihara. These are the parametric equations for, we learned this in PCH last week.
Hyperbola.
No,
Ellipse. Circle.
Is it actually?
Square.
Angelo.
Inner loop.
Represent Mr. Ye's class.
Cardio.
Cardioid.
No.
I've asked for help.
Phone a friend.
No.
Who are you gonna ask?
Ian,
Bryson.
ask Ian.
Bryson Choi?
Why
Okay.
would you?
What?
Okay, Olga.
What?
Okay, well, okay, you're kind of remembering it wrong. Brachistochrone is like a property, is a property of a cycloid. This is the cycloid.
Cardio. Inner loop.
The Bakista is
No, no, you guys are doing polar. Some of you are doing polar.
Wait, inner loop is polar?
That's the one.
Okay, wait, where did my,
I didn't, is it multiple?
where did my,
Because like Bakista is like a segment.
no, I had
Any
a
segment
masking
they
tape
choose
roll
from.
over here.
I don't know.
Where did it
I
go?
think that might be it.
I need that to teach you the cycloid.
We took that last
Yeah, I know we did it, but nobody's remembering anything.
It's so hungry.
Why don't you remember anything, Trent?
Okay, here.
What song are we on, Trent?
I just fell last year.
I couldn't find it.
I got it.
Oh.
Okay, suppose you have a line like this, and you have a circle on this line, like this, and it's going, this circle is going to roll on this line without slipping. That's a term from physics, yeah? Here is a point on the circle.
There is friction.
So as this circle rolls on the line without slipping, the path traced out by this point here is a cycloid.
Semicircle.
No, it is not. Could have been an engineer. Could have been an engineer, but no. Take pain. Okay.
If we just took the chunk.
It just reached.
Like this, and you did the thing.
Okay, look. I'm gonna roll this thing without slipping on the thing.
Do
Watch.
you need help?
Let's just use gravity. Look.
Oh.
Watch. Just watch this point now.
Free body diagram.
Here you go.
Oh,
Look at that point.
Too much friction.
Oh, you said my
Hey, where's the chocolate?
You just said that.
Yeah, I said it to myself, but you can't tell me that. The masking tape is stupid. Anyway, so the path traced out by the particle, it looks like this. Doing. If you keep rolling, it is not a semicircle.
Semi-ellipse.
It is no. It's a cycloid. Does this look familiar from last year? No?
It's a parabola.
Abi?
It's half of a
Lee?
table.
See? Finally!
Yes.
What's the thing inside the circle?
Okay, now, some of the properties of the cycloid are this. Okay, what if you had a contest? You have to build a ramp under the influence of gravity. You're going to release like a ball bearing or something. You have to take it from point A to point B. How would you build this ramp? Just get a straight board like that?
No.
No!
Cycloid.
You build it in an inverted, upside down cycloid like that.
Oh, you should
You know why? Because at the very beginning, you
Yeah,
have like
that's
a vertical drop, that's why. Whereas if you had a straight board, the thing is going to go slow, then it's going to speed up. But since you're starting with a vertical drop, it's just like dropping up and going, "Grang."
Potential energy changes to kinetic energy.
Okay, and then, of course you know this, right? What if somebody were to release the marble there, and somebody were to release a marble there? Who would get to the bottom first? They get there at the same time. That's why cycloids are so important. And here's another graph that's going to come up in tonight's homework. What would happen if you have a circle, and you have a smaller circle that's 1/4 the radius of the big one?
Cycloid.
What would happen if I take the circle
Oh, no, you get that
and roll
star
it
thing.
without slipping on the inside of
The
the
four
circle?
sides.
You would get a hypocycloid
Oh my
of
god.
4 cusps.
Coming back.
You guys know what a cusp is, right? In fact, the other class, you know, PCH this year, they told me, you had Mr. Masunaga, they said, Mr. Masunaga wants you to draw your arrows with a cusp at the end like that.
Oh, yeah.
Yeah.
Really?
That's how
Yeah.
engineers call it.
How come you can remember that?
Mr. Park, you
I
should have
slept
became
in
an
that
engineer.
class. I was with Natalie.
And what would happen if you have
I know.
a circle 1/4 the radius of the big one, but you roll it on the outside of it?
Exocycloid.
So it's gonna go like bling. Oh, somebody remembered it? There you go. It's called the epicycloid.
Hyposa.
So this is the
Electronic
hypocycloid of 4 cusps. This is called an epicycloid.
Looks like a sunflower.
Sunflower forecast.
Okay, I'm telling you, these two are gonna come up in tonight's
It's a
homework.
4-leaf clover.
Okay, now this is what you gotta do in tonight's homework. You're gonna have to compute the arc length, the length of the arc
Oh my.
of the cycloid and the hypocycloid. It's easy. Okay, do we know how to find the length of curve?
No.
Of course.
Yeah, remember how I derived those formulas way back
Or
when?
ydx squared.
Oh.
Square root 1
Okay,
plus.
okay, wait. Tran, what integral will give you the length of curve? Integral from x1 to
Come
x2,
on.
square root of
1 plus dy dx squared. dx.
That's important, guys. Yeah, but Mr. Park, parametric equations are given in terms of t, so we need this integral to be in terms of t. So you know what? I'm going to derive it all over again.
What?
No, because you guys just
go to lunchroom.
okay. Suppose you have a length of curve. I take a infinitesimally small piece like that. Looks like that, right? If you zoom in like 100 times. So what do? We make it like a right triangle like that. What is this infinitesimally small change in x? dx. What is this infinitesimally small change in y? dy. Using the Pythagorean theorem, what is that then? The square root of dx squared plus dy squared, right? That represents the length of that tiny piece of curve, and then we just simply add them all up. Now, this is what we have so far. Okay? Let's enlarge it right there. Now, if I want to do this integral in terms of t, I need to somehow get a dt out here. How can I get a dt out here? Just like, how did this dx come out here? I showed it to you.
Divide by the end.
Okay, so inside the radical, I am going to multiply top and bottom by dt quantity squared. This dt comes out of the radical as absolute value of dt, but since it's a length, it's going to be positive. And then now lift and separate. What is dx squared over dt squared? Dx dt squared. What is dy squared over dt squared? Dy dt squared. So this represents an infinitesimally small piece of the curve. So if you want the whole curve, you simply add up all these pieces from t1 to t2. This is how you compute the length of the curve. Okay, so all we have to do is compute the length of this and we're going to lunch.
Oh my.
Yes.
Okay, so the cycloid, remember, it goes, so if you roll the ball, it goes dunk. I want to know what is the length, the arc length right there. So, first of all, let's get the limits of integration. Right when you push the ball, not the ball, what is it? The circle, t is 0. What is the value of t over here? When it hits the ground again. Is it pi? 2 pi? Pi over 2?
Try, guess and check.
I don't know.
Okay, let me call it Tamura. Captain!
Let's see. 2
pi.
2 pi.
2 pi, you're right.
Yeah.
How did you figure that out?
Plug in 2
Yeah.
pi, guess and check.
Okay, there you go. Right, because when is the next time the y coordinate's going to be 0? When you plug in 2 pi, 1 minus 1, right? Okay, so let's do this. Integral from 0 to 2 pi, square root of dx dt squared plus dy dt squared. Okay, here's x. We need dx dt and we need dy dt. I'm going to be calling on people. Who's got this first one? Wong, dx dt. I have eyes behind me. Go.
1 minus cosine t.
Okay. And then Hanuman, dy dt.
Sine. T.
Okay. Throw it into the formula. So you got 1 minus cosine t squared plus sine t squared dt. Now the question is, can we do this integral by hand, or are we going to take out our calculator?
And
Or
Check
let's see.
calculator.
I'm pretty sure you're going to do it by hand. Okay, so multiply it out. Who's got this? Who's multiplying this out? Who?
1 minus 2 cosine t plus cosine squared t. Actually, plus sine squared t.
Ooh,
Oh, you somebody.
Hey, you somebody. 1.
1 minus 1, 0.
Cancel out the ones. Cancel out the ones, Trent. So what? Play the drums at the wrong time.
The wrong song.
here we
Sorry,
are.
I was playing Eight of Vice when there's no drums in Eight of Vice.
Actually,
Oh, you know what made me cry last night?
you
You
cried?
cried?
No, I no. Yeah, I
Inside.
did. I can admit it.
You cried?
I cried. Why is that so hard to believe?
I thought you just get mad.
His children.
Or hungry.
Yeah, that's true.
Hungry, mad, or happy. There's no sad.
You know when the children are starting to sing "The Hills Are Alive" when the captain came home?
It's spoiled.
It's in the movie.
I didn't
It's
even watch
in
the
the movie. It made me cry.
Really? Were you with your wife?
Yeah, but she knows I cry and stuff.
In the very
Aw.
does she make you cry?
The big softie.
Oh yeah, she makes me cry.
Oh, softly.
No, like
Just a big
never
teddy
mind.
bear.
Okay, now how do I do this integral?
You
Take
it
out
like
the two.
this. 1.
Trick substitution.
Please sit down. Factor out of root 2, and you get this. No, you guys.
Lopita.
No, we're not gonna leave until we do this integral. I'm gonna keep asking. Ewer, what should I do?
You're.
Ewer, right?
You're.
It's like your and
Your.
mine. You are.
Natalie, how do you do this integral? Okay, I'll give you a hint. Hey, it looks kind of like an identity, you know.
Do you do the cosine GT one? That's cosine squared one.
Okay, you could, but hey, you almost somebody. You're almost somebody.
1 minus cosine
Oh, it's
squared.
by
Tangent.
Oh, okay, there you go. So inside the radical, your
Oh.
said multiply top and bottom by 2 like that.
And then put on the outside.
And then this radical 2 can come out like that, yeah? Hey, you somebody!
Double angle.
Cosine 2.
No,
Half
not
angle.
half angle.
Oh.
Tangent.
Wait, let me call on somebody.
Not.
Abe. I heard the oboe last night.
Oh, did you hear my octave?
It's not even.
I had a solo and a solo.
No, see, you can't tell. Unless you have the music in front of you, you can't tell if you make a mistake.
Pretty good. Not so much.
Okay, stop stalling and stop stalling. This is the identity for
Sine half t.
okay, close.
Cosine.
Okay, no, you go first. Okay, let me write it down. Sine theta over 2 is equal to plus or minus the square root of 1 minus cosine theta all over 2, which means 1 minus cosine theta over 2 is equal to sine squared theta over 2.
But it could be negative.
Yeah, so you gotta watch out now. So what is this then, right there? According to this identity.
Boomerang.
Sine squared t over 2. What is the square root of sine squared t over 2? It's the absolute value of sine of t over 2. Now that makes a difference here because from 0 to 2 pi, sometimes sine becomes negative, right? So if you're smart, what would you do?
4 times integral from
Break it up.
pi
Break it
sine
Wait, I just, you know, wait. You know what? Somebody just said, look, Hanuman, very good. Hanuman said it's always positive. She's right.
0 to 2.
Because 0 to 2 pi, it's going to go, if
Oh,
you plug
0
it,
to pi.
it goes to pi, because this is, yeah,
Break it
so
up, break
it's,
it up,
it is
break it up.
positive. Oh, darn it, I wanted you to like think, but again, obviously you don't have to. Okay, so you don't need the absolute value. What is the antiderivative of sine of t over 2? Is it just negative cosine t over 2?
That's 2.
No, I left the space for another 2 there. And then you gotta go from 0 to 2 pi. Factor out the constant, so you got negative 4, plug in the top number.
-1.
Negative 1, minus, plug in the bottom number. 1, final answer, 8. So this is 8 units long. 1 arc of the cycloid.
We just got a jet.
Okay, so tonight's homework, isn't this pretty mechanical?
All right.
Yeah, I think it's pretty mechanical.
Alien, bailing, insane.
All right, let's go to lunch. The test is on Monday.
Oh, thank you, everybody.
Oh, please.
There's our substitute teacher.
No!
No!
Put down that camera!
Put down
this camera!
Ah!